Thanks everyone for joining this session. I'm Clarke, a senior consultant in our technical pre-sales team at Esri UK. The theme of today's conference is creating the world we want to see. But we don't have to look very far to see the threat of extreme weather events here in the UK. In Bristol, where I live, high tides and storms coincided in March and April, affecting both local residents and the infrastructure of the region. So how can we use the power of location to ensure we are prepared to respond to these extreme weather events? Well, over the next 15 minutes or so, I'm going to explain how you can monitor change using real-time data in ArcGIS Dashboards. I'll begin by briefly running through the real-time offerings in ArcGIS. I'll then move on to the creation of the dashboard, before finally touching on some additional configuration options, including mobile views and adding custom code. But let's start with a brief recap of real-time data. Generally, it can be grouped into three categories. Firstly, things that move and change over time: vehicles, aeroplanes, or even people. Secondly, things that are stationary but have a measurement or value that changes over time. Think about an air quality sensor or a stream gauge. And thirdly, one-time events that happen in space and time, a lightning strike or a crime event. Alongside this sensor data, real-time data can be collected in the field using one of our ArcGIS mobile applications, as well as using the apps to add, update, and edit data. ArcGIS Quick Capture, Survey 123, and Field Maps all support location tracking, allowing you to see the live location of your workforce in the field. With the growth of sensor data and Internet of Things devices, more and more organizations are interested in using this real-time data to increase situational awareness and improve their decision-making. In order to gain insights from this real-time data, you need to ensure it's ingested into the system and processed ready to use in your maps and apps. There are several different options within ArcGIS, and the one that's right for your organization will depend on a few different factors. Running through those options briefly, firstly, we have ArcGIS Velocity, our cloud-native add-on capability for ArcGIS Online, allowing users to ingest data as well as providing big data analysis and processing capabilities. If you're working in enterprise, then ArcGIS GeoEvent Server offers similar capabilities but deployed on-premise within your organization's architecture. If you're looking for batch processing, then we have ArcGIS Notebooks, available in both online and enterprise. It's a Jupyter Notebook experience optimized for spatial analysis. And finally, the newest offering to ArcGIS Online, Data Pipelines, a native data integration tool offering a fast and efficient way to ingest, maintain, and prepare your data, all with a drag-and-drop user interface. I'm not going to spend any longer talking about these products, so if you have any questions, then please come and find me at the end of this session. Don't forget, we also have lots of live feeds available in the Living Atlas, from the current weather to live traffic and even recent earthquakes. These datasets are immediately available for you to add to your maps and apps. Whichever route you choose, you're going to need a tool to visualize this data and share your insights with others, which brings me nicely onto the next section, creating a dashboard. Making the most of real-time data is more than just tracking dots on a map. It's about gaining insights and sharing these with others to improve your operations. In today's live demo, I'm going to show you how I created this dashboard to monitor a fictional flood event in Bristol. Ensuring multiple agencies have access to up-to-date data is vital to ensure an efficient and effective evacuation of local residents. As well as facilitating this situational awareness, users can interact with the data, answering key questions they have in seconds to improve their decision-making. This is just a fictional scenario, but were this a live flood event, data would be updated in the field by emergency responders and volunteers using both field maps and Survey 123. This can then be complemented with live sensor data. In my dashboard, I've chosen to add 2 live feeds from the Living Atlas. The first is the latest weather, which I've filtered to the nearest weather station, allowing me to check if there are any weather systems moving into the region that might impact the response. And secondly, the latest traffic service, so emergency responders can check for any incidents and choose the most effective evacuation routes. You may also choose to include a live feed of CCTV images from the city centre, giving users a feel for the conditions on the ground. In order to help with this situational awareness in my dashboard, I've also included a 3D web scene to give users a sense for where the flood is impacting the city centre. But let's rewind to Map Viewer and I'll take you through how I configured this dashboard. Firstly, looking at the data I've included, I have ward boundaries in the area, the flood extent, and the address points within this flooded area. I've symbolised these based on whether the properties have been evacuated or whether they still need to be unchecked in yellow. I also have the location of 5 rest centres that have been activated for this flood response. These points also include information on the capacity, and I'll make use of this information later. I also have some points of interest, including the location of hospitals, police stations, and schools. And then finally, my 2 live feeds from the Living Atlas, which I just showed you. I'll create my dashboard directly from Map Viewer by using the Create App button and choosing Dashboards. Once I give my dashboard a suitable title, it will load up with my map occupying 100% of the screen. The menu on the left-hand side is where I can begin to configure my dashboard. I can add a custom theme, configure different views, and begin to add elements. Elements are what allow you to visualize your data in a meaningful way in a dashboard, and I'll begin by adding an indicator. I'll select it from the list, and the first thing I need to do is choose the data source. I want to have an indicator of the number of properties that are affected in this flood, so I'll choose my address points, and you'll see the default statistic count loads, but there are lots of other options too. Looking under the Indicator tab, I can add some text to show users what this figure represents. I'll also add an icon to make it really obvious what this figure is. Underneath the General tab, I can add a title and a description if I feel users need some more context around this figure, and I can also toggle on the last update text, which is really important in the context of this real-time data. I'll press Done, and the indicator will be loaded into my dashboard. By clicking on the 3 dots, I can drag this element into a new position or stack it on top of existing elements. I'll leave it where it is for now, and I'll add another element. This time, I'll choose a gauge. While it's useful for me to know the total number of properties that are affected by this flood, I want users to be able to see how many of these properties have been safely evacuated. Again, I'll choose my address points as my data source, but this time I'll add a filter where the status equals evacuated. I can see my gauge has updated, but I need to show this value as a proportion of the total properties, so I need to remember to also update my maximum value. I can see my gauge is updated, and I'll move on to the gauge settings where I can choose how I want this gauge to look. I'll stick with the horseshoe shape for now, but underneath value, I'm going to switch this to a percentage, as I feel users will be able to get a much better understanding from this figure. Underneath General, I'm going to add a title so users know what this figure represents. And again, I'll toggle on the last update text. I'll click Done, and again, this indicator loads straight into my dashboard. Now, in the interest of time, I'm going to switch forward to a newer version of my dashboard. And the first thing you'll probably notice is this dashboard looks quite different to the previous one. And this is because I've added a custom theme using these shades of blue. If I open up the View menu, I can also see all the other elements in my dashboard. I've added a list to show the activated rest centers. I've added the 3D map stacked behind my original map, as well as a pie chart. I've also got a header with a title. So while I'm happy that my dashboard is beginning to show some key information for emergency responders, users currently can't interact with this data at all. So the next thing I want to do is configure some actions. I'll open up the settings of my pie chart and switch to the Actions tab. I have the option to choose a selection mode, single or multiple, and various different options when a user clicks on a segment. If I open up Filter, I'll begin to toggle on all the other elements linked to these address points. I can see by the little symbol that this is the same data source as my pie chart is coming from. So I'll add the rest of those indicators. I'll click Done and I can test that this is working as expected. When I click on a segment of my pie chart, both the map and the property count is updating as I wanted. You'll also remember that I had the ward boundaries loaded into my map, and I also want users to be able to filter by these areas. I'll add another element, this time within my header, and I'll choose Category Selector. I'll switch this to Features, and I can choose which layer I want this to be from. I'll pick my ward boundaries, and I'll update the code to the name to make it easier to understand. I can see a preview of this selector on the right-hand side. Again, I want to open up my actions and ensure I've configured these. Expanding Filter, I'll go down and click my address points. But as this is no longer the same data source, I now need to choose whether the method will be fields or spatial. My addresses don't have the ward field within them, so I need this to be a spatial filter. And I'll go and do this same thing for all the other address elements. I'm also going to add a none option to my category selector if users don't want to filter by this area. Again, I can test this is working by choosing the central ward, and I can see my map has been filtered and also my indicators too. So now users can get a feel for this key information just by glancing at the dashboard, but they can interact with elements if they need to find out more information. Now, as you can see, there's lots of different ways you can customize your dashboard with elements and that custom theme. But while this dashboard works well on a desktop view, I need to be aware that some users will be out in the field on the go using a mobile device. So I also want to ensure I've got a mobile view configured. This can be done under the View menu again, and I'll press the option to add a mobile view. A blank screen loads and you have two options. You can add completely new elements to your mobile view, or you can copy elements from your desktop view. I'm going to choose to firstly copy my map, and then I'll choose my total properties indicator and my pie chart. Again, just like before on the desktop view, I can stack elements and rearrange them till I'm happy. Be cautious not to add too many elements to a mobile view, as your screen space is much more limited. On a mobile view, when you copy elements, all the configuration is copied apart from the actions. To add the ward selector to my mobile view, I need to open up my drawer settings. I'll press Add a Drawer, and then I can copy the selector over. As the actions aren't copied, I need to make sure I go and configure these to again filter my elements. On a mobile view, this filter sits at the bottom, and again, I can test it's working as expected. Under the Settings menu, this is where you can also add a splash screen if you want to present users with some more information when they first open up the dashboard. So that's my desktop view and my mobile view almost sorted, but there's a final thing I want to do with my list. Now, as you can notice on the left-hand side, this list is coloured, and this is based on the occupancy of each rest centre. The ones in green have an occupancy below 50%, the one in red is over 75%. This is configured using Arcade code, and if you're new to Arcade, it's a lightweight expression language that you can use to create custom content in ArcGIS applications. If I open up the configuration options of my list and go to the List tab, you can see that I've enabled advanced formatting. Now, I know that every time someone arrives at a rest centre, they're going to be registered via a Survey 123 form, and this means that I have the information on the number of people there, as well as the capacity of the rest centres. I've used Arcade code to firstly calculate the occupancy using these two values. I've then defined what colours I want to show depending on this value. If the occupancy is under 50%, I'll use green, and if it's over 75%, I'll use red. I finish off by returning both this new value and the colours at the bottom, and click Done. Now, as well as defining those expressions, you also need to configure your line item template, which is where you choose what data you want to show in your list. You can see that I've got my field name as well as my new expression. These are all accessed from the Insert menu, where you'll see any new expressions you make alongside your field values. The final step was adding some HTML to choose how this list is displayed. But if you're not a coder, you don't need to worry, because there's lots of resources out there and dashboard examples that you can use to copy and paste code from to get started, and I'd highly recommend to give it a try. So there you have my final dashboard, making use of real-time data from both sensors and the information collected in the field, ensuring emergency responders have access to all the latest information. My 3D scene provides additional context for users, and they can dynamically interact with the map, seeing the extent of the flood. Users can also interact with the data, answering any key questions they have and aiding their decision-making. If you have any questions on anything I've shown today, then please come and see me afterwards, and I'll also be in the tech zone during the final break. Thanks for listening.